All right, let's go ahead and get started. Welcome everybody to the Visualization Friday Forum. It's nice to see a good crowd here. We still have, just to let you know, we still have one more week left. Next week we'll have our last one of the talk of the semester. Just like always, I'm going to start out by sending around the sign-up sheet. If you haven't been here before, it's just to keep track of how many people we have from what departments, so we can justify our food budget. There's a final column here. If you are not on our mailing list and would like to be, please legibly write your email address in that column, and we'll just send you the once-a-week emails letting you know what the talks are. I'm going to try sending it up the side first. We'll stake it around somehow, see if it can get over to the other side at the end. Let's see. I don't think there are any other announcements this week. I'm really happy to have Hedges and Dave here talking about the DiVE and the new upgrades. When Hedges Copper took over the DiVE from, used to be Rachel Brady, who started this talk series, used to be in charge of the DiVE, Hedges had a big job ahead of him to try to keep the DiVE relevant for research, get more things happening, get grants, and he has done a really great job in leading the DiVE and moving it forward. And one of the big achievements is this big NSF equipment grant that they got. And so what they're going to be talking about is the upgrades that were possible with that grant. But I think it's great to see, because the DiVE is a great partner. Hedges and Dave are great partners for all over campus. People, they end up working with people from visual studies and from engineering and from all over, both for coursework and for research, and I'm glad that they've been able to keep it really successful and moving forward. So, what? Oh yeah, thank you. The other thing is that Hedges is one of the main contributors. We had two great donors for the food this semester, and Hedges is one of the main contributors for the food. So if you've enjoyed the food and us being able to have food at the Friday Forum, it's a big part, thanks to Hedges. So, welcome, guys.
We get dinner too.
Not the science, it's just the food.
Dinner too.
Yeah, let's do that. Yeah, thanks for the introduction, Eric. So, Dave and I today are going to talk a little about the upgrades that we've done to the DiVE, and also some of the projects that really show the span of interdisciplinarity research and educational progress that we do in the DiVE. So the DiVE is basically us here. We basically run and maintain the DiVE, and of course we have several faculty members from different departments and schools in the university that we work with. But this is sort of the support people for the DiVE. We also work a lot with students, and these are all undergraduate students who have done or are still doing projects with the DiVE. And when I talk about the DiVE, I talk about the whole lab. So we do have the DiVE cave, which is the main piece of equipment and what we're going to be talking mostly about today. But we also have, as Dave's going to say, we have other devices like Oculus Rifts and immersive desktop displays. We have different tracking systems. So we do not only do research with the DiVE, but we also do research that's really intended to you either advance the state of the art with advanced human-computer interfaces, or that can benefit from advanced human-computer interfaces. So just to describe a little bit the award that really allowed us to upgrade the DiVE to a relevant current state and really keep us going for many years to come. We got an NSF Major Research Instrumentation Award, and that's basically an equipment grant. In the proposal, really, what really made it happen, and I'm quite confident about it from the reviews that we got, is two things. One is the level of interdisciplinary research that has been done and that is proposed to happen with the DiVE for years to come. So in the proposal, we had 14 different projects spanning 3 disciplines: engineering, humanities, and the sciences, with 11 different research areas. So you see there's really a lot of interest from people in using such a display, and my job really is to facilitate that and to be a collaborator in the technical and interactive visualization aspects of these projects. The other strength really important for this proposal was the broader impact, and we were able to show the applicability of such a tool for different research areas. NSF really values that. They want to see research that can cross discipline, that can be used by a broad range of people in a university environment, and I believe we're able to show that. But also the outreach component for the DiVE, the fact that we welcome school groups to visit, to get involved. We've had many times before, and we still welcome high school students to come and spend a summer in the DiVE. We also have a focus on minority, which is also something strong for NSF. Our proposal was, and this was also made us feel a little even more happy about this award, is that it was reviewed by 2 panels. Typically, any research proposal is reviewed by a single panel, and we suggested the proposal to be reviewed by behavior and cognitive sciences, which is a lot of the research that we do and that has been done in the DiVE. But also, once they got the proposal, they saw that they were able to analyze the intellectual aspect of the proposal, but they weren't able to assess the technical aspects of it. So they called up computer network systems to also evaluate. And we got top reviews in both. So we got an A review for BCS, which only 3 of the 19 proposals got, and we got a high recommendation from CNS, which was also the top review. And of course, that made us get this award. Terms monetary, we got about $400,000, and Duke was really great about providing matching funds, which are required for this type of proposal. So we got 30% from the provost office, the total of $570,000 for the experience. So this is what the DiVE looks like now. It's been a challenging. We are not, and we really welcome 3D modelers. We are not, definitely we cannot even render something properly if we have the model. So this is something that Dave was actually able to do from a 3D, and we didn't have a lot of time. We only got this model a couple of days ago from Christy, who did the upgrade. But basically what we have now, and we're gonna go more in detail later, we have 2 projectors at each wall, and this is the major difference. Before we had a single projector projecting what would be a projector capable of doing a wide screen 16:9 aspect ratio, really just projecting a square, so we lost a lot of pixels in the middle. Right now we have 2 high def projectors, a little higher than high def, projecting at the top half and bottom half. We also made other changes that Dave is going to talk about in a minute. Okay, so let's look at how was the upgrade. Unfortunately, we only got the surveillance camera. We have a camera now in the DiVE while the upgrade was starting. So we don't have a picture of what it looked like before, but this is how it looked like in between, which was, there was nothing there. And this is how it looked at the end. So let's see a little video about this upgrade. So we got, actually we're saving every 10 seconds of the upgrade, of everything of video in the DiVE, and then we did this time-lapse video. So this took about a little over 2 weeks, maybe 18 days or so. And the biggest challenge was the overhead projectors, because these are not like consumer level projectors. They are rather heavy. The Christie people actually had to put reinforcements up in you can see there, because the structure is all plastic really. So to avoid interference with magnetic tracking system when it was originally built. So they put reinforcements there, they mounted the projectors. And now it's getting to an alignment stage where we get, again, Dave's going to talk about that. The alignment is done initially in hardware, basically aligning the projectors, and the structures have a lot of mounts and or adjustments, but then there's software for that. So I'm going to turn it over to Dave so that he can talk about networks.
Great, so now we're going to go over some of the nitty-gritty details of what we actually did to upgrade the system. This is kind of the overview slide. We're going to actually break it down into each one of these categories, but just as a high-level view, we upgraded the projectors, which the end result was we got higher resolution, brighter images, and a higher frame rate. We upgraded the GPU, the graphics cards. This is going to allow us to do larger models and to get better lighting from some of the more advanced shaders. We upgraded the shutter glasses. And this is really great because they go into RF, so we have no line of sight issues, which I'll talk about more later. And finally, we upgraded the tracking system with some more emitters. You can see there's an emitter upgrade there, which gives us better tracking coverage of the space. So, talking about that first item, back when we started in 2005, you can see we started with the Christie Mirage S+2K projectors. Now, as Hedges said, this was actually chopped off, so our actual resolution per wall was something like 1050 by 1050. So a little bit low. I mean, the pixels are about, at that point, they're about 3 millimeters for each pixel, so it's actually pretty visible. You can see now with the new projectors, which are the Christie Mirage WU7K projectors, they're actually above HD, so regular HD would kind of be 1920 by 1080. These are actually 1920 by 1200. We'll explain in the next slide that actually helps with the blend zone being a little bit taller than your standard HD resolution. But the main thing we get is we're actually stacking them up here. You can see this is how an actual picture of the door wall. And that gives us, for each wall, and it's a cube, so there's 6 walls, we actually get 1920 by 1920, so you can see that we get a pretty big upgrade in resolution, almost 3 or 4 times the resolution. Another thing is with the Christie Mirage S+2K, if you look at the data sheets, they say it runs at 120 hertz, but if anyone here has worked with stereo projectors, it runs at 120 hertz, at a resolution much lower than its native resolution. So when we were trying to push it, we were only able to get it actually up to 110 hertz before the image started breaking up. Now with the new projectors, we're able to run at this full resolution at 120 hertz completely fine. That's what they were designed for, and it works out great. So what this means is that the smoothness, the number of frames per second that the projector is refreshing, we actually got a little bit of an increase in our new system. And then finally, we can look at the lumens, which is kind of a measure of the brightness of the projectors. We get an increase from there, and then we get another increase because we're doubling it up.
So Dave, with that frequency, does that mean 60 hertz per eye?
Yeah, so we'll get into that. I'll explain that when we get to the glasses, but yeah, our old system was running, at 55 frames a second. This is kind of an effective of 60 frames per second. Okay. Yeah, so you may ask yourself, well, you got these projectors stacked on top of each other. Usually the first question then is, how do you do that? And it turns out we're actually overlapping the projectors. This is actually a hypothetical blend. I'm actually not sure what the exact blend pattern we're using is, but I just wanted to show an example of what it would look like. The problem is if we were trying to project white, for example, on both screens, top and bottom, because there's an overlap, if we don't fade out during the overlap zone, you're actually going to get a bright spot. And so it's very important that you have this blend zone over here between the two. Also because it's really hard to get the alignment to be exact easy, and on a lot of our walls now, it's pretty seamless. I actually had seen some other systems before and was, when Christie talked about blending, I wasn't super excited about it, but I think part of it too is that we have a pretty large blend zone here. a lot of having the 1200 resolution on the vertical resolution on each screen, it really allows us to have a large blend zone, which gives you a lot to work with when it comes into setting it up. Now, in terms of how the blending happens and how the alignment happens between the two of them, it's aligned a little bit mechanically on the stands. You know, you can turn some bolts and move the thing up and down, and the lens can move a little bit too, kind of electromechanically. But a bulk of the fine alignment, there's this module inside the projector. It's the Christie twist module. And what's nice about that is by doing all of the alignment in the hardware, it's really invisible to the end applications what's going on in terms of the blending or the alignment. And it's further invisible by the fact on our graphics cards, which I'll talk about in a second, there's a feature they call Premium Mosaic. So what this means is that we get a single, this appears to the applications as a single image, a single desktop, 1920 by 1920. So in terms of configuration, especially when we're upgrading from the previous system, the system still thinks it's one wall. Even though it's two separate projectors, by doing the blending and by doing the Premium Mosaic, it basically still feels like we just have a bigger single wall. Okay? So we also upgraded the graphics cards. When we first started the system, when it first came online in 2005, we actually had the NVIDIA Quadro FX 3000 cards, a whopping 256 megabytes of video memory. They expect to do about 100 million triangles per second. You can see there was a couple years into the system, we did do an upgrade of the graphics cards to the FX 5600s, which gave us a bunch more memory, more performance. But we actually acquired the NVIDIA Quadro K6000 cards for our system. I think there's a couple of things that are interesting about this. One of them, when I was looking at this chart, it's interesting that the clock speed hasn't gotten really fast. Really, it seems the way the graphics cards companies are solving this problem of needing increasing performance is just to throw tons of cores at the problem. I mean, each one of those cards now, you can see over there, has 2,800 cores, which is a lot, and a lot of memory too. And the one caveat to this is it'll make more sense when I get to the system diagram, but we are running one card per wall, so we are doing more graphical work. So you could argue that we might have to divide this by maybe two, maybe less, but it's still an upgrade, pretty big upgrade over our previous generation of cards. Okay, another thing we upgraded was the shutter glasses. Is anyone familiar with how the shutter glasses work in the DiVE? Well, I guess I should talk about it then. So there's a lot of different ways you can do stereo. If you think back to the 50s and 60s, you know, everyone's wearing the red and blue glasses. Anyone remember red and blue glasses? Okay, some people, that's good. But basically the idea is to get stereo, the end goal, doesn't matter how you do it, there's a lot of different ways, but you want to get a separate image to each eye. So the red-blue was just a way to put an image up on the screen that was filtered differently, and the red lets only red images pass and the blue pass. More modern, you know, go out to see a 3D movie, you're going to see polarized lenses as being pretty common, where you'll have a different polarization angle on the two. Those usually work pretty well, although if they're linear polarized, you do get into issues where if you tilt your head, it'll start to become, you'll start to see the images really ghost real bad. The type of stereo we use in the DiVE is actually called active stereo. You can also think of this as interleaved stereo. So what's happening is very quickly the projector is projecting left frame, right frame, left frame, right frame. Now, so the glasses, the image doesn't come from the glasses, but the glasses are a part of the whole process. So the projectors, for example, will project the image for the right eye. But you only want that image to go to the right eye. So the glasses, this right here, these are actually kind of electrical LCD panels. When you apply voltage to it, it'll go dark. So it'll cover up your left eye. So all the projectors are showing the right image. The glasses are going to cover up your left eye. Then the whole process reverses, covers up your right eye, and the projectors show just an image for your left eye. So the whole magic of 3D is really providing a separate image for each eye. You get an independent image that's rendered from a slightly different perspective, and your brain puts it together. And that's kind of the magic of how 3D works. So getting into our previous system we had these kind of infrared emitters. So you talk about how do the glasses know whether to show the right eye or the left eye? And it's by sending this pulse from the system, from the IR. And it works pretty well, but unfortunately the IR is kind of a line of sight system. So you can think of IR as being like, your remote control on a TV, or at least how they used to be. Maybe they're RF now too. But anyway, so basically if there's something blocking this emitter to the glasses, what do you think happens?
Screwed up.
Yeah, all of a sudden you're not seeing in stereo right. And this was actually a big problem in a lot of our tours, especially when you start, when you're just in the cave system, in our dive system by yourself, it's fine. You're probably not going to have any line of sight issues. But you're in there, 5 or 6 other people, all of a sudden there's people blocking this emitters, which were located outside the system, projecting in. You're blocking that. The great thing about the new glasses is we got RF glasses, and they are just great because it's RF, radio frequency. The signal gets transmitted in every direction, goes right through everything, and so we are not getting this. We've been testing this for the last month or so. We started doing some tours, and this is a really great upgrade in terms of, especially when you've got like some more people in the dive.
Is there still one person who's like the center person, everybody else keys off of them?
Yeah, there's still the idea. I'll talk about that a little bit in the tracking slide, but we still have kind of the rendering is being done by a tracking unit that's mounted on one user's head. And as you look around, that data gets transmitted. We didn't adjust that kind of thing. Okay, yeah, speaking of the tracking system, upgrades. We got upgrade of the InnerSense tracking system. You can see this is, there's 2 things actually. So we're tracking the head of one of the users. So ideally, as you look around, the position and the orientation is transmitted back to the master computer, which then kind of inserts a virtual camera into the scene. So kind of that ability of being able to move your head and have the camera move inside the system is kind of what closes the perceptual loop, which allows your brain to start believing that you're inside the virtual world. The other, I don't have that picture on here, but it's just a little sensor that we mount on top of one of the pairs of glasses. But this is actually the hand controller. Lately, just to make it easier to describe to people, I tell people it's like a 3D mouse. It gives you back a position anywhere in space and an orientation. You can see here, just upgrading to the latest system. It's a little sleeker, a little nicer. It plugs into a dock, which is really nice. Just pop it in there, starts recharging. But the other side of the upgrades for the tracking system is we installed additional emitters. It's a little hard to see in this diagram. This is kind of the door that swings open right here. And so originally, we had emitters in the blue here on kind of the back 2 seams vertically, and then up around the top. So what they did, and that's pretty good, but you might guess from this what one of our problems might be, and that is that we always had problems with the original tracking system getting near the floor. You start to get too far away from these upper emitters, and it makes it really difficult because we have this one demonstration environment. It's a virtual kitchen. People drop stuff on the floor, and the first thing they do is they try to bend down, pick it up. We're actually able to do that now because we've got some of these emitters down here, so it actually doesn't lose tracking as bad when we get near the floor. Okay, let's look at a confusing system diagram because I know some of you in the audience really want to know how this whole thing is set up, right? Anyone? Okay, I got 1 or 2 people, so everyone else can just sleep, take a nap for a little bit. But this is the confusing system diagram of how our system technically is actually put together. And so I should remind you, this is just the diagram for a single wall. Remember, we have 6 walls or 6 surfaces in our dive system. So imagine this diagram being replicated 6 more times. So I'll walk you through it a little bit. So we kept the original, the Dell T7400 nodes. Those were actually upgraded about 5 years ago. We didn't upgrade those, but we did manage, as I talked about before, we did manage to upgrade the graphics cards. Here you can see a single graphics card. It's got 2 DVI outputs here. These go to some Extron DL201 extenders. Really great. They can extend dual-link DVIs at 120 hertz up to 100 feet. So it's really great. The disadvantage, though, is there's 3 Cat6 cables. So I was pulling a lot of cable termination. Anyone ever terminated Ethernet? Oh, you know what I'm talking about. So there's a lot of Cat6 Ethernet that we installed for this. Okay, and then once it gets up, so this is down in the machine room. This is downstairs in the basement. Is all this stuff on the left side of the slide is hidden. There's a bunch of Cat6 cables coming up through a hole in the floor. It shows up to the projector stand here, and it's kind of mounted around the back of the stand actually, are the receivers that take the Cat6 cables, convert it back to DVI. The DVI, one DVI plugs into the bottom projector, other one to the top. So this is kind of the infrastructure, how it gets from the basement all the way upstairs. In the actual machine rack, there's one other little detail, which is we have to use the Quadro sync cards, which is the professional grade NVIDIA cards, for one really good reason, is that they provide the NVIDIA Quadro sync card. So by having this in the thing, actually this cable, okay, coming out of here would be plugged into a board in the next T7400. What this does is it allows us to kind of frame lock all the computers so when they refresh, they're all refreshing at exactly the same time. If you don't have that, if it's kind of softer, you can get into these weird tearing issues where if you're looking at the seam between two edges, it's not going to look right. Okay. As I just was saying, we do most of our work is with the DiVE system, which is a cave-type environment. However, in the CMOS 1411 development lab, we also are doing experiments and research with some other VR devices, a Z-Space, which is a VR workbench, Oculus Rift, Razer Hydra, which provides kind of the tracking similar to what we get out of the Intercept. Okay, covering briefly some of the software libraries that we're currently using. How do we do projects? Software is actually, especially my specialty, so I can talk a lot about this, but I'll give you just a brief overview. We've got Aviso, which anyone, Avisa? Anyone? Oh, wow. Okay. Well, some people around Duke are using Aviso, and one of the things you might see when you come for a demo, sometimes we show people the 3D brain. It's got slices. Can move through it. It's really great. Aviso is really good for that kind of loading in stacks of slices stuff. We use Syzygy for kind of low-level C++ OpenGL stuff. It's open source, so we can distribute it to anyone. That's still the same. Previously, for a lot of our things, like I talked about the kitchen, for example, one of our great demos, we actually developed that using Virtools, which is a game engine, which is great because it gives you all kinds of effects, artificial intelligence, physics, sound, all that makes it very easy when you use a game engine. However, back around 2010, the company switched products, stopped developing Virtools, so we're kind of looking for a solution on how to move forward. So we've actually decided that we're going to now use Unity for our game engine, and that is one of the big new things that we're doing for software libraries. Now you may ask yourself, well, Unity's pretty cool, but how do you use Unity with this big, clustered system where each wall has its own computer? So we're talking 6 computers plus a 7th master node. That's not something Unity supports out of the box. So we actually needed to get a plugin. There's a guy, Sebastian Kuntz. He has a small company called Middle VR. And basically, I don't know, it's a little hard to see on here, but you can load in this plugin, drag the VR manager kind of into your Unity scene, and then you get all these options over here. But what it really lets you do is without recompiling or adjusting your system or adjusting your Unity project, you can actually then run your project between the DiVE, the Z-Space, or the Oculus Rift. And this is really important too because a lot of times people will make an application in the DiVE and they want to, maybe take it a little more portably, take it out to the Oculus Rift. Or the other thing is, especially when you get into pure VR research, it's kind of the comparisons that are interesting. It's very nice to be able to run studies where you can compare, well, how is the user experience or performance really different between, a cave-type system and the Oculus head-mounted display system? Okay, let's talk about, that's kind of the hardware update, hopefully not too boring. Now we'll talk about some of the projects that we've done over the last year, just to give you a sample of some of the scope. So actually about a month or two ago, me and Hedges went to Arles, France for the IEEE Virtual Reality Conference. This is really great. We presented some work there that we've been doing with Hirakash and Mark. It's called Exploring the Effects of Image Persistence in Low Frame Rate Virtual Environments. Basically, the idea of this is that when you have a really low frame rate, so ideally we'd be running at 50, 60 frames a second, keep constantly updating. However, you can get into situations, especially if you have too big of a model. Maybe you have too many polygons, too many textures, everything starts running slow. The updates are just happening much slower. So we were trying to explore that a little bit, and so normally what happens is you render the frame And because the projector is still running at 50 or 60 frames a second, it just repeats that frame. So we did this little experiment where we're trying to see what happens if we apply the low persistence technique, which people have done kind of in higher frame rate devices. What if we apply that in low frame rate devices? And it is interesting because with the HP condition, we do get some sort of artifacts as you look around, kind of this like doubling of lines. You can even see this, I see this a lot now when I'm watching like Netflix when the scene pans. You get like all these like artifacts, and that's one of the causes. But then the bad thing about low persistence is you would imagine by putting all these showing a frame and then showing just black frames for a while, it does give it this like pulsing strobe effect, which is not the best either. Anyway, so we ran some user studies. We had a selection task where users were picking this dot. The dot was just stationary. And we found that the full frame rate, the high frame rate condition was faster, but we weren't really seeing a lot of differences between these two conditions, which was interesting. We also did a navigation task where the user navigated down a hallway. There again got similar things where there wasn't a whole lot of difference between the low persistence and the high persistence case. But we have some ideas for some future work. We're actually about to begin working on it for this summer, how to continue this study. One of the big limitations of our original study is all the targets were fixed. We're wondering especially how this could change if the targets are in motion. We've also just started to collaborate with Professor Greg Applebaum, who's actually, I think, given some Friday Forum talks here. He does the Nike stroboscopic glasses, which are really cool for sports training, and so he's really an expert on vision and kind of stroboscopic type displays. Let's talk about another thing that we worked on within the last year. And actually, all these happened in the summer and the fall, so kind of before we took our old system offline. We're just now, we've only in the last month started doing stuff with the new system. This has all been work that we were doing last summer and fall. Anyway, so we were talking about perceptual load. This is actually an interesting psychological theory that says distraction is stronger when perceptual load is low rather than high. So they do these kind of examples, a lot of it's on computers where they'll flash this thing to you, and this is considered a low perceptual load system. Your goal, this is the target, and this is what you're supposed to ignore. And the theory is that when you go to this higher perceptual load thing, that this doesn't provide as much of a distraction. I guess just the whole task is so much harder that you don't see a big increase. So we tried to replicate, this kind of idea. It's normally done with these letters on a screen. We're like, okay, well, we'll do it with arrangement of objects in a virtual environment. The user's trying to, it's kind of different between this one, the cola's the target, and you're supposed to ignore the outside one. This one, you're trying to say, is the cola in the scene? Or what position is it in? In this case, it's the yogurt. So this is the low load. It's supposed to be very easy to find your target because it's red. It kind of pops out at you. The high perceptual load is trickier. So the interesting thing about these results is they're contrary to the theory. The distractor effect is not modulated by low. If this whole thing followed the psychological theory exactly, this would cut off right here. You wouldn't see an increase between the incongruent case. But we're still seeing that. So why is this interesting? Well, it's interesting because, a lot of psychological research does this stuff where it's like very simple stimuli popping up on a computer screen. I think VR really provides a way to test some of these theories. Well, these are interesting theories, but shouldn't they also work in the real world in a more realistic environment? So I think VR is really interesting to test traditional research in more complex, ecologically valid scenarios, although it might be challenging because it might not give us the results we're expecting. Just some other quick projects we've been doing. Actually, just this morning we were meeting, kind of wrapping up the details of this. We've been working with the Masters of Engineering Management program. They've been working with Gilbane, who's actually working on building the Duke Health and Wellness Center. This is kind of a pre-visualization of one of the exam rooms. Pre-visualization is becoming a really big topic in architecture, and so we're doing some of that. And then we've been, next week actually, we did it last year. Next week I'm actually going to be working with Joe Nadal. He teaches CE 429, it's a civil engineering class. It's really great. We get to bring the students' final projects into the DiVE. They get to experience flying around with them. And so this is going to be, this is what we're doing in Unity now. So we've no longer using Virtuals. We're bringing the models into Unity and we're able to fly around and make everything happen.
So these are starting out in some regular architectural
Yeah.
CAD program.
Yeah, so both of these were in Rivet,
Okay.
and then they output to an FBX format, and then we dropped the FBX format so far seems to drop pretty well into Unity. And that's all the projects I have. Hedges is going to talk about some more.
All right, so another project that we're doing, Ayana Perkins, actually, she's here in the audience. She's a computer science junior, and she's a computer science undergraduate research scholarship fellow. And we're doing this project using the Oculus Rift. So we started doing this project. The DiVE was coming down for the upgrade. So she has actually implemented the initial implementation of the system in the DiVE, and then she moved to the Oculus. Of course, she's using Unity, so she can, with Miro VR, so she could easily go to the Oculus. But we presented this project. Ayana went to France with us, and she presented a poster of this project showing a pilot evaluation. And the idea here is to investigate whether using spatial audio as wayfinding cues, meaning as you walk through an environment, you start hearing sounds in the location of places, sounds that are meaningful for the place that you are going through. Is that going to help you remembering where things are and building a spatial map of the environment where you are? So the idea here is that we use two mall or maze type environment, which are malls. So you walk through, you had a guided exploration where you had things like you passed through a coffee shop and then you heard sort of chatter in the background. You could pass through a playground, you hear kids shouting, that sort of thing, a movie theater and all that. Or you had a condition where you had absolutely no sound. And you still got the landmarks, you got the billboards and everything, but no sound. And the idea was to see what the effect there was in some follow-up tasks of both pointing where things were in the environment and also going back to one specific place in the environment. So these are some results from a pilot evaluation. So Ayana just finished running the full study with 16 participants. Because we only used 4 participants to sort of see if we could find some trends and just do a pilot, really. And we found some interesting things. Of course, this is nothing statistical. This is all just observations. But all participants were able to, in the last task where they had to fly back to, or not fly, but to travel back to a specific point, they were fast when they had sound during training. They never had sound in the assessment phase where they had to go. And here gives an example of the same person going to, of course, these are different, but they are mirrored mazes. So the person wasn't going to the same place, but it was same level of difficulty. When they had sound during the training phase, they got a little lost, they went off, but they were eventually able to find the target rather easy. And when you look when they had sound, they went onto a lot more like diversion. They were like got 2 or 3 wrong turns until they were ultimately able to find the target. The other thing was pointing. So we asked participants we basically blanked out the environment and asked them to point the wand or the Razer Hydro controller in the direction where they believed different landmarks were. And we got pretty consistent so this is an average for all the participants, all the 4 participants in the 2 malls blue line or blue bar is without sound and orange is with sound. And the pointing error was almost always smaller with sound than without sound in both cases. Smaller or equivalent. Of course, nothing statistical, we're looking into that data. One thing is that I looked at the averages and it's still consistent with the larger pool of participants. We didn't run any statistics yet.
Was it mono or stereo audio?
It was stereo and spatial. So the audio was rendered in the position. So Unity is great because it allows you to do that very easily. You basically put a virtual speaker in the environment, and then you could hear. So yeah, that helped. We believe that helped a lot. You could hear sound coming from a particular part. Okay, another project that we've been doing, this is with support of Best Connections, and it's an archaeology project. The idea is to do a reconstruction of archaeological sites in virtual reality so that we can preserve the archaeology that's very destructive in nature. Again, it's multiple platform. We can do that. We've done that in the Oculus Rift, but we're going to do that in the DiVE. These are some stills, but let's look at a video that actually Nicola Lercari, who was a postdoc here, he is just being hired as an assistant professor at UC Merced, produced. So here is the system. Basically, this it looks sort of distorted because that's a distortion that needs to be done so that when you look through the Oculus, things look straight and right. So basically, what you can do, you can fly through the dig site and you can pick up things. So these are sort of what has been discovered during the process of excavation. And the process is you scan the environment, then you excavate, then you scan again, excavate. So you have several layers that you can look through. And this was in a Turkey dig site that they're finishing up the excavation, and everything is sort of very down to deep layers. But with these reconstructions, we can see things. For example, here there's a skeleton. There was a burial ground inside one of these houses. Let me fast forward a little to show you some of the features that we have here. So one thing that we do now support is a metaphor of a tablet. So you're actually holding a physical, and it's what we call near field haptics. So you're holding a tablet, a physical tablet, but you're looking through a virtual tablet. And that helps you a lot because it's very natural. You bring down the tablet, you don't see anything anymore. Anytime you need to see information about the environment, you bring the tablet back up. So it's a very natural user interface. And this is also querying a real-time database that's in Stanford about this project. So you get data, everything is geo-referenced, so you get the real information about the artifacts and static graphic units that you're looking at.
Hedges, with the tablet, is it using the accelerometers in the tablet itself to measure?
Yeah, that's a good question. Actually, we attached another tracker to the tablet. So the Razer Hydra has two controllers.
Okay.
One of them is attached to the tablet so that it's tracked in 6 degrees of freedom. Okay, so the last project I'm going to talk very briefly. This was done with Rebecca Bennett, who was a postdoc fellow with the Wired Lab. And the idea here was to see how an immersive 3D environment would be useful for analysis of remote sensing archaeological data. So here you see that with satellite data, you can start seeing patterns in landscapes that could show civilizations from many centuries ago. But with the advent of LiDAR, which is laser radar, we can actually see depth with going through like vegetation, that sort of thing. We can start seeing a lot more features that we cannot see just in the pure aerial photograph. So there were 4 types of displays that people could go through, and I'm going to show the environments in a second. We had the DiVE, a desktop, a 3D desktop, and a 2D GIS. But you can see, for example, there are some features here that you can see in this type of LiDAR, local relief, that you cannot see here. And this is sort of a filtered version, hue shade, that you can see some of this. I'm sure that a lot of you are much more familiar with this than I am. So we implemented in Virtuals with help of DiVE a DiVE visualization a 3D web application that was basically a web version of the virtual app, and the 2D GIS application. We used expert and inexperienced participants, and the idea was that participants would have to make archaeological observations during the experience. So first I'm going to apologize for these pie charts. I know they're terrible. That's the only data that I have here that Rebecca sent me. But basically we can see here some things, although with a bar it would be much easier. The cave was preferred overall. The GIS was least preferred overall. Most people who were specialists, they thought the DiVE, the caves, the DiVE, was most suitable about half the time, and there was kind of an even split between 3D web and GIS. And non-specialists, nobody liked GIS because just the 2D GIS is so complex. If you don't have training, you cannot use, so people prefer either 3D web or the DiVE. And the number of observations, there wasn't really so much of a difference between experts and non-experts, but the GIS provided the most number of observations along with the 3D web. And we believe that that's a feature of the environment, the way that the landscapes were implemented. They're really flat, so we didn't have a lot of the 3 dimensions, and we're just flying through a very large environment, which took you longer to do so than with the GIS or even the 3D web. So we think that if some changes to the interface are done, we would be able to get more stronger results for the immersive environment. Okay, so wrapping up here, if you want to get involved with the DiVE, there are several courses across campus in engineering, in visual media studies, ISIS, that use the DiVE as a component. If you want to do a capstone project, you can, depending on where you are, you can talk to me or you can talk to Victoria Zabo or Raquel De Prada from VMS, and we could do a project with the DiVE. We have work study opportunities for students who are under financial assistance or volunteering, and then we really rely on students to give tours for the DiVE. We also have students volunteering with projects and just improving their own knowledge, and website development and maintenance. Also, I'm always looking for collaborators in the faculty. So if you have any projects that you think could benefit from immersive visualization, I'd be happy to talk to you, and we could see how we could get that into the DiVE or into a more immersive interface. And always I'm looking for grant opportunities. So again, I'm talking always, I've been talking to different people, but always want to find where there's a good match of some ideas that could benefit from my expertise in human-computer interaction and immersive environments with the particular domain area. Just a plug here for a course that I will be teaching this spring. It's ISIS 320, Introduction to Interaction Design in Virtual Environments. Basically, we cover concepts of HCI and virtual reality technology. It's really about user experience and user-centered design applied to 3D interfaces, and it's really project heavy. So the course is we look at theory and research, but towards developing a project. And this also can be taken as a computer science independent study, and then just some of the requirement changes in terms of just coding and documentation, that sort of thing, but we can do that. Okay, so last slide, we do open houses every Tuesday from 4 to 5, open to the public in the DiVE. You can experience different applications that we've done there. It's first come, first serve, so you're welcome to come any Tuesday. Thanks, and if you have any questions.
Questions? Hey, Mr. Dave?
Yeah, sure.
So I was interested in the cognitive processing, the visual with oral cues, the audio cues. The person who's working on that project, have they, or do you know if there's been any discussion on the sort of medical center side? You know, Alzheimer's patients lose their visual spatial cognitive processing. It's one of the first things that enters into the cognitive dysfunction. And while they're still able to function in other ways, it'd be really interesting if there's some way of training them with the audio so that they can still find their way to places that they're still normally going to without getting lost.
That's interesting, and that actually I think relates to two of the projects that we talked about. One is with the spatial neglect, which is one thing that initially for that project we were, the intention was to use stroke patients, but then it's for the time frame that our collaborator was going to be here, she's from Germany, wouldn't be able to do that. But for this, yeah, I think that's a very interesting idea. Actually, Ayana is here, we can chat with her after, but yeah, I think to use that to aid patients who may be losing spatial abilities could be something nice. And really in real life, we could do that, not just in VR.
It has kind of twofold benefits. One is obviously help in doing something, the cognitive processing, but with a lot of practice and repetitiveness, it could actually, who knows, perhaps even delay the cognitive decline. It'd be a great research question to test by practicing that over and over and over a period of time, and then looking before and after in the same people.
Yeah, that's
Versus
great.
the normal people that you were looking,
Yeah.
I don't mean not normal, but normal controls.
Yeah,
One more question, and then we'll have to wrap up the room.
So in terms of the glasses and the one person being the
Perspective,
feedback,
right.
perspective, so then it's an individual experience, but other people can be sort of observing. You can't like play tennis or have two people.
Yeah.
So is it that isn't doable yet, or you just didn't have the money with this grant to do it, but with money it could be done right now? Or I'm just interested.
So
in,
if you have $10 million, probably you could do that. There are like a couple prototype systems in the world that can generate 2 or 3, or in this case 4 or 6 viewpoints. But the main challenge is getting the frame rate to update at the rate, like you need 240 hertz in order to be able to show 60 frames per second per eye. So one thing though that I can tell you is that there is a colleague of mine from Germany. His name is Bernd Frohlich. He works a lot with hardware design, and he's told me that they're coming up with a projector that can do 4 viewports at a time, 240 hertz. And that's probably gonna be about $500,000 per projector or something like that. But it's something that's coming up. And so that's one thing that the big challenge I think Dave can say a little about this is having it in full color, because these are like color wheels. If we did just monochrome projections, it could go up to like 2,000 or 3,000 hertz, right?
Yeah, I think there's been some experiments. People have gotten some black and white DLP projectors up to 1,000 hertz, but it does get to be a timing thing and a persistence thing, because then if you're showing the image for less time, it's going to be perceived as dimmer. So there's some, at a certain point, if you want to play tennis, it might be good to just build a second cave system.
Well, no, but
It's
that's
a good thing, yeah.
Are there like network Oculus?
Yeah, that's certainly one thing that we can that can be done, and I'm talking to a friend of mine from Texas to do some projects with that. Yeah, but yeah, I agree with you, especially if you want to do cooperative work, to have 2 people working on the same environment but having different perspectives. That would be great.
All right, they're going to need the room soon, so let's thank Hedges and David. And did the sign-up sheet make it anywhere over there? And please recycle your cans in, I don't know where it is now.